Good afternoon, integrated topic students. For today's class, you're going to need loose leaf paper for notes. We're going to switch over to inequalities. You're going to need a calculator if you want, and the drill review, which reviews everything that we did with linear equations from last class. So speaking of the drill review, we went over it, give them some time to do it, went over it. And the first thing it says, the cost Y of renting a kayak is $5 plus $2 times the number of hours that the kayak is used. Assume that X can be a fractional part of an hour. So what fractional part means, you can have a half an hour, you can have a quarter of an hour, you can have 3/4 of an hour. And the first section says, write an equation that expresses the relationship between X and Y. So based on the information that we have, they're telling us that cost is going to be our Y and the hours is going to be my X. Just renting it is going to cost me $5 plus $2 on every hour. So if I were to write this out, I would have Y equals 5 plus 2X. The Y is representing my cost is, that meaning equals, 5 plus 2 times X. So using this information, I'm going to review a little bit on graphing. So remember, in order to graph, you had to put in that slope-intercept form. If you don't remember that, remember it was Y equals mx plus b. The m represented my slope, aka rise over run, aka, I know it's a lot of AKAs, right? Rate of change. Yeah, believe that that's change. And then my b was my y-intercept. So y-intercept is just another way of saying starting point. So now let's look at our equation. Before we can do any kind of graphing, you guys need to tell me, remember from left to right is my x-axis and up and down is my y-axis. What's going to represent my x-axis? So my x-axis, is another way of saying that, is my independent variable. My independent variable deals with what's changing. So what's constantly changing? So in this case, it's going to be my hours. And you can count your hours by ones, you can count them by twos, you can count them by threes, but whatever you decide, it has to be on that constant bear. So it can't be like, okay, let me start count 1, 2, then you go 4, 6, 8. No. If you're going to count by ones, continue counting by ones. If you're going to count by twos, continue counting by twos. So now my y's. Y's is my dependent variable. So my dependent variable is usually what's being measured. So what's being measured in this case is the cost in dollars. So how much is it going to cost me after I spend a certain amount of hours in the kayak? So based on the equation, y equals m plus 2x, y equals 5 plus 2x, got m on the brain, we're going to start at my y-intercept. When you're graphing, always look at that y-intercept. So my y-intercept is going to be 5. And I want to count my y's by 1. And it's going to be a little tight. So it's going to look a little sloppy. So that's why I really didn't do all that. So I'll put my mark on 5. And from here, I'm going to look at what's constantly changing. What is my rate of change? And in this case, my rate of change is going to be the $2. So for every hour, I have to pay $2 from this $5 starting point. So if I were to do that, okay, it cost me $2, so that's 1, 2 for every hour, which is 1. It cost me another $2, 1, 2 for every hour, which is 1. Cost me $2, 1, 2 for every hour, that's 1. Do we see a pattern? So every time you go up 2 and you go over to the right 1 because you're increasing your hours. If you notice, eventually, we're going to have a nice straight line. Okay? So for every cost, for every $2, I increase by 1 hour. So part C says use your graph to find how many hours a kayak was rented if the total cost was $16. So if I continued on, because I know I stopped it a little prematurely, if I continued on, I started at 5. If I add $2, that'll be 7. If I add $2, that'll be 9. If I add $2, that'll be 11. If I add another $2, that'll be 13. If I add another $2, that'll be 15. Okay? If I continue on with the 15, that 15 would have taken me where it was at 5 hours. Okay? But we want to know when it's going to be $16. Because I know if I went to 6 hours, that'll be $17. So if it was at 5 hours, it was $15. And for 6 hours, it'll be $17. That means 16's got to be somewhere in between. So my assumption would be that it would take 5.5 hours for me for the cost to be $16. But there's a way that I can check this. So if I go back to my equation, and I can take this $16 and plug it in for the y. Okay? So when I do that, I got 16 equals 5 plus 2x. And we can go ahead and solve this for x. So subtract 5. So I have 11 equals 2x. Then divide both sides by 2. So now I got 5.5 equals x. 5.5 is the same as what we assumed was 5.5 hours. Okay? So we basically did this as a review to get ourselves ready for inequalities. So the first step for us to solve an inequalities, we're going to solve it with just one variable, just like how last time we did with 2 variables. But I want to break this down first by solving for 1 variable. Then the next class we're going to solve for 2 variables. And then we're going to get into the graphing and eventually getting into the system of it. So when we did the drill, that was to help bring back all those concepts that we did by using equations. This time, we're doing the same type of sequencing, but we're using inequalities. So you're solving it exactly the same way. So that, please excuse my dear Aunt Sally, is going to come into play. Adding, subtracting, multiplying, dividing. But there's one thing that's crucial when it comes to inequalities. When you're multiplying or dividing by a negative number, that's going to cause the inequality, that symbol, to flip or change directions. Okay? That's huge. And I'm going to show you why. Okay? You still solve everything exactly the same. So for example, I have negative 7x is less than 28. So if I went ahead and solved this, I would just simply divide both sides by negative 7. And I would get x, and I would get a negative 4. Let's just say I did not change the sign. Okay? Let's just say I just left it as is. If I wanted to check this, I can plug that negative 4 in for the x. And if I do that, I'll get a negative 28 is less than 28. Now, when it comes to inequalities, unlike linear equations, we usually just got one solution. Okay, maybe some solutions, as long as those solutions are on that line, that's perfectly fine. But with inequalities, there's a wider span of solutions. There's a wider span of answers that are correct pertaining to our inequality. So when we're solving for inequalities, we're looking for true statements. So now going back to this negative 28 is less than 28. Or I'm sorry, not negative 28. That would be a positive 28. Is less than 28. Now, is that a true statement? No. The only way that that can be a true statement if it said less than or equal to 28. Okay? So now if I go back to this x is less than negative 4, what other number can be less than negative 4? How about negative 5? Okay? If I plugged in a negative 5 for an x, I have negative 7 times negative 5, and that will give me 35 is less than 28. Now, is that a true statement? No, because we all know that 35 is definitely bigger or greater than 28, not less than. So you got to think of the number line. You're thinking, well, negative 5 is larger. No, it's not. If you think of the number line, let's say that's 0. Got negative 1, negative 2, negative 3. Okay? And on the number line, if you're going to the left, your numbers are getting smaller. Okay? As opposed to going to the right where you're getting all the positive numbers. So your numbers are getting bigger or larger. Okay? So if I plugged in, I don't know, like a negative 7. Okay, negative 7 is all the way down here. If I plugged in negative 7, I'm going to get a 49. So negative 7 times negative 7, that'll give me 49. 49 less than 28, is that a true statement? No, it's not. So this is why we have this rule. When you're multiplying or dividing by a negative number, that's why this sign has to flip. So now, let's think of a number that's larger than negative 4. So we can say negative 1. If I plugged in a negative 1 for the x, I would have 7 is less than 28. Now, is that a true statement? Yes, it is, because 7 is less than 28. If I plug the 0 in for the x, I would have 0 is less than 28, because anything times 0 is 0. So I'm going back to the original equations. Okay? 0 is clearly less than 28, so that's why it's a true statement. This is the reason why we change the sign when we're dealing with negative numbers, because we're looking for a true statement. If we keep it the same and you go ahead and test it, you will clearly see that you're not going to get a true statement if you leave that sign the way it is. Okay? So now, class notes. So take the notes as written. Okay? There's times I'm looking through notes and I really don't know how you guys are following. I really don't know, because I have some numbers over here, some numbers over there. It's all kinds of cookaboo. So anyway, when we do this, we want to follow the examples. We're still solving just like how we normally would. So when I solve this, I want to solve it one side at a time. So for me, first thing, I got this negative 2, and I want to distribute that negative 2 to everything inside the parenthesis. Okay? Once I do that, I get 3D minus 16D plus 18. Okay? Now, ask myself, is there anything else I can combine? Yeah, I can combine the 3D and the negative 16D, and I get a negative 13D. And I bring down that plus 18. Now, is there anything else on this side I can combine? No. So I'm going to leave that side alone. Now, let's try the other side. So you always want to do one side at a time. Okay? Look to see what you have. So now on this side, we have 3 minus 2d plus 7. Anytime you see a minus sign and a parenthesis, there's always a 1 assumed to be there. So I'm actually distributing a negative 1 to both sides. And when I do that, I get negative 2d minus 7, and I'm bringing down my 3. Now, is there anything over here that I can combine? Yes. I can combine this 3, and I can combine this negative 7, which, as a result, will give me a negative 4, and I bring down that minus 2d. So can I combine these? No, I can't. So let me get rid of my shade, and let me write down my inequality. So now, we're going to solve this inequality just like we would an equation. So remember, the equation is like the barrier. Let me see if I can draw myself a barrier. Okay, we'll do this. Okay, cannot cross that line. So that means my ultimate goal still stays the same. I need to put my variables on one side, and then I need to put my constants or my numbers on the other side of that barrier. So I can do one of two things. I can add 2d on both sides, or I can add 13d on both sides. It all depends on what you like to see. So if I add 2d, that means I'm saying that I want my d's on the left side of the inequality. That means this 18 has got to go. And how I do that? I'm going to subtract 18 on both sides. All I'm doing is combining two steps into one. So my 18s cancel out, my 2d's cancel out. So I have a negative 11d on this side and a negative 22 on that side. And I still keep my inequality here. So now I'm solving it again. I got to divide both sides by negative 11. So that means my d, and it's going to be 2 on that side. So I got a d on the left side, I got a 2 on the right side. Since I divided by a negative 11, that means this sign right here has to flip. So instead of a greater than symbol, it will be a less than symbol. So any number less than 2 would make my original inequality a true statement. So if I can think of anything less than 2, if I wanted to put a 1 where the d's are, I'm going to get a true statement. If I want to put 0 where the d's are, okay, 3 times 0 is 0, 8 times 0 is 0. So I got a negative 2 times a negative 9, which will give me a positive 18. So then I have my 2d, that will be 0. Okay, and then I'll have a negative 21. So let's see, 18 is greater than negative 21. Is that a true statement? Yes, it is. So that means our inequality that we found was correct. All I did was put zeros where the d's were and did the multiplication. Okay? So number 2, did the same thing. Do one side, then do the other side. So for this side, I distribute. So I have 8t minus 16 minus 3t plus 12. I can combine my t's, so I got 5t minus 4, and I can't combine anymore. So that side we're going to leave alone. This side, I got my 5t minus 35 plus 8, and I can combine those, and I got 5t minus 27, and I can't combine anymore, so the screen goes away, and I'm putting my inequality. So now, I want all my t's on the same side, so I'm going to take this t and put it over here. I know, wait for it. So when these cancel out, but guess what? These cancel out as well. So I'm left with a negative 4 is less than a negative 27. Is that a true statement? No, it's not. So we have what's called, remember this, no solution. Since that is not a true statement, therefore we do not have a solution for this inequality. The next one. Remember, please excuse my dear Aunt Sally. So right now, I need to isolate this variable. So that means this negative 2, that's going to be the first to go, because right now that's not a part of my division. So I have a negative d over 5 is less than 25. And then the opposite of division is multiplication. I could multiply both sides by 5 to cancel out these two 5's. But I'm going to be left with a negative d. So why not kill two birds with one stone? Instead of multiplying both sides by a positive 5, why don't we multiply it by a negative 5? So when we do that, we also cancel out the negatives. I know, right? So since we multiply both sides by a negative 5, that sign's going to flip, which will give me d is greater than a negative 125. So remember, anytime you multiply or divide by a negative number, the signs flip. So anytime that you want to stop and take a look at things, go ahead and do that. I'm just writing this down as a reference. So this time I want to multiply both sides by 5. So let me ask you, does my signs change? No, they do not. Okay, I'm multiplying by a positive number. So the signs do not flip. So now I'm just basically solving like I normally would. Okay, then I got 38. Divide both sides by 2. Now does my sign flip this time? No, it doesn't, because I'm dividing by a positive number. So W is going to be greater than or equal to 19. That means if I plug 19 back into my original equation, it should work because of that equal to symbol. So now, word problems. I'm going to do this real quick. So a number, we don't know what that number is, so we're going to say x, decreased by 5 is less than. Remember, less than, the arrow always points to the left, 33. So you have x minus 5 is less than 33. That's your equation. So if we add 5 on both sides, they're saying that x is less than 38. Okay? So for the most part, oops, speeding along here. For the most part, this is basically what we've done for today's class. Practice up on solving a one variable, and the homework was to complete one of the riddle or the joke activities that I have. I'm going to try to put that on the website, but right now, based on so many propagandas, it's going to be kind of hard to put it on. but I will try my best to put it on for you guys. All right? So, any questions and comments, just come see me during Wildcat Hour. All right, guys. Good luck. Bye.